Your students probably know that electricity is transmitted at high voltages using cables strung between tall pylons. I'm going to show you a demonstration that you can use to explain why we need the high voltages. Now, you can buy specialist apparatus to do this, but I'm using equipment that you should already have in your lab. What I've got here is a low voltage alternating current power supply. It provides a fixed output of about 2 volts. I'm using it to represent a power station. I've connected a bulb to it here, which represents a home close to the power station. And then I've connected an identical bulb through this circuit using these nichrome wires to represent the power cables, and where the bulb represents a second home far from the power station. Now watch what happens when I turn the power on. Now you can see that there's a clear difference in the brightness of the bulbs. The bulb close to the power station lights up brightly, whereas the bulb further away is significantly dimmer. To understand this, it helps to measure the voltages in the circuit. Now, what I've got here is a multimeter that I'm using as an AC voltmeter. And if I connect it across the first bulb, I get a reading of 1.9 volts. If I now connect the voltmeter to the power cables, I've got a potential difference between them of 1.9 volts. If I now move about halfway along the cables, I've got a reading of 1.3 volts between them. By the time I've got to the second bulb, the voltage has dropped right down to about 0.8 of a volt. Now, this problem is solved in the national grid by using transformers to step up the voltage as the current leaves the power station, and then to step it back down before it goes into our homes. And we can do the same thing with this demonstration. I've got a transformer here with a turns ratio of 20:1. I'm going to use it to step up the voltage from the power supply. I've got an identical transformer at the other end that I'm going to use in reverse to step the voltage back down. Watch what happens when I turn it on this time. You can see that both the bulbs are lit with approximately the same brightness. And let's look at the voltages. At this end, closest to the power station, the potential difference between the wires is 42.6 volts. At the far end, it's only slightly less at 42.5. And down here, I've got a voltage of 1.7 volts. Now, this is a really great demonstration for showing why transformers are crucial to power transmission. And it's a great way of introducing the topic before you explain it in terms of voltage, power, and current. This apparatus is perfectly safe to use, but there's a couple of things you should bear in mind. It's important to use a low voltage supply with a fixed output of no more than about 2 volts. Choose your transformer here so that when you step up the voltage to here, it's no more than about 40 volts. At this end, it's really important that you connect the transformer the right way round, so you're definitely stepping down the voltage. If you get these things right, you won't come to any harm.